Hello everyone, my name is Chandusai and I'm going to present a project on data transmission and reception using 802.11 application framework with NI USRP-2942 via OFDM. Our objective is to customize and develop a way in which the data can be transferred wirelessly through various versions of 802.11 standard. The transmission is made using the OFDM modulation scheme. By analyzing, we get the best transmission parameters for various specific aspects. LabVIEW NXG. It is a next-generation graphical programming environment. It provides various application frameworks that enable us to implement real-time wireless standards. The table shown here depicts the various standards of 802 family. 802.11 application framework. Out of the many frameworks provided by the LabVIEW, we use the 802.11 application framework. It is comprised of PHY and MAC blocks implemented using LabVIEW. The block diagram of the entire transmission and reception is shown here. It includes mainly three sections: host, FPGA and RF hardware. The packets from the host are sent to FPGA section wherein channel encoding and OFDM modulation occurs and is later transmitted through the RF hardware. Upon receiving, the packets are first synchronized with the time and frequency and later passed through OFDM demodulator and channel decoder. Channel estimation and synchronization are also done in between to reduce the errors. It is a clear view of reception as I have explained in the previous slide. We use ICP, which is Inter-Process Communication Protocol, for the communication between PHY and MAC layers. Orthogonal Frequency Division Multiplexing. OFDM. In OFDM, multiple carriers carry the information stream simultaneously in the form of digital data. Frequency channel allocation. Wi-Fi uses two bands for communication, 2.4 GHz and 5 GHz. Here, our interest lies in the range of 2.4 GHz frequency. According to IEEE, we use the 83.5 MHz bandwidth for Wi-Fi. Internal layers. The MAC layer is divided into upper, middle and lower MACs respectively. The lower MAC and PHY layer are implemented on FPGA while middle MAC is implemented on the host. We can have the MAC layer functionalities and the PHY layer functionalities shown here. CSMA. CSMA is the carrier sense multiple access. It uses three strategies: interframe space, contention window and acknowledgement. These are used to implement its functionalities. It is a basic block diagram which overviews the encoding and decoding along with estimation and equalization for removing the redundancies. Setup. This picture shows the loopback connection between transmitter and receiver from channel 0 to channel 1. The arrow mark shown here indicates the power spectrum. The arrow mark shows the connection between host and the hardware. The graphs and the indicator in the figure indicate the power spectrum, constellations and control channel information with throughput. It depicts the status of data transmission. We can notice the number of packets sent from each layer from transmission and packet drops in between, and finally the number of packets received at the receiver. The figure shows the various types of ways in data transmission. By seeing the number of data packets that were dropped, we can observe that there was minimum failure and efficiency is well improved. Thank you.